Hello everyone. In this video I am going to teach you how to find duplicate elements in the array. Duplicate elements means if the element is repeated more than once, that is called duplicate element. We should find that duplicate element in this array. Now this array is sorted array. Now this array is of size 10. N equals to 10. Now I am filling elements in this array. Now it's sorted. Suppose this is the elements are in present in array, in sorted array. Now see. Now the output should be the duplicate elements presented in this array. What are the duplicate elements? 6 is repeated twice. 6 is present here twice. So 6 is the duplicate. Then see 12 is present here 3 times. So 12 is a duplicate. So it should print 6 and 12. How to find the duplicate elements in this array? Let's see. See. Now I is at 0. I is at pointing 0. Now you should check whether a of I equals to a of I plus 1. Whether phi is equals to 6. No. So then I value will be here. Then check whether the 6 equals to this 6. Yeah. So you should print 6 as duplicate. Now 6 is duplicate. You should print a of I is duplicate element. Now after printing you should increase I value. Then see. You should check whether 6 is equals to 7. No. So it's not duplicate. Now you should go to this position. Now you should check whether 7 equals to 8. No. So you can increase I value. Now I is at this position. You should check whether a of I equals to a of I plus 1. 8 is not equals to 10. So you can increase I value. Now check whether a of I equals to a of I plus 1. 10 is not equals to 12. So you can increase I value. Now check whether this a of I equals to a of I plus 1. 12 is equals to 12. So you should print 12 as the duplicate element. Now increase I value. Now you should again check whether 12 is equals to this 12. Yeah. So 12 gets printed again. Now I value gets increased. Now check whether a of I equals to a of I plus 1. No, 12 is not equals to 15. So you can't print. Now I value is here. Then it stops. But see, the output should be 6 and 12 because 6 and 12 are duplicate elements. But here see, here 6 is there, then 12 is printed 2 times. But 12, you should print the duplicate elements, but not the number of times it's repeated, you should not print. But here 12 is repeated, 12 is printed twice. So removing this error, there is one condition. Let's see that how to write a code for that. Let's see now. See now. Now at starting I am writing last duplicate equals to 0. What is this last duplicate? I'll say now see at starting no duplicate element is found at before starting this loop. So I'm writing it as 0. That last duplicate is used to remove this error. This 12 is repeated twice, right? So for printing it one time, so this last duplicate variable is used. Let's see how. Now see. Now I'm writing for loop for I equals to 0, comma I less than n, comma I plus plus. Now this loop is used for traveling I from 0 to 9. I is at starting 0. Now you want to check duplicate element in this array. So from 0 to 9 you should move. For that I am writing this loop. Now I am checking the condition, writing the condition. If a of I equals to a of I plus 1. What is this condition? I am checking whether phi equals to 6, whether 6 equals to 6, like that. For that, for duplicate element I want to check, right? So I am writing this condition. And another condition also I am writing. See, a of I not equals to last duplicate. What is this? Why I am writing this condition? A of I should not be equals to last duplicate. For removing this error, 12 and 12 is repeated twice, right? So I should remove that error. That let's see how, why, that's why I'm writing the statement a of I should not be equals to last duplicate. Let's see why we are writing it. How? Now see, if you found the duplicate element, that is a of I equals to a of I plus 1, and this condition a of I not equals to last duplicate, then you should print the statement. print the duplicate element. See, print f percentage d is duplicate, percentage d is duplicate. Now you should write what is the duplicate element. See, what is this percentage d? Now you're comparing, suppose see, this I value is 1. So you're comparing a of I and a of I plus 1. Now, yeah, 6 is equals to 6. So you should print a of I. That is 6. So you should print a of I is duplicate. So I'm writing here a of I. This a of I is percentage d. Now see, now after this you should update last duplicate value. Now in this case last duplicate is 6 because 6 is duplicate, it's found first, so you are mentioning duplicate is 6. Before it was 0, now it's 6. So last duplicate is equals to a of I. This is a of I, so you should mention it. Now this is the code for finding a duplicate element in sorted array. Now see, let's trace this code. Now see, I is at 0. Now it's checking whether 5 equals to 6. No, so it doesn't enter into this enter into the statement. Now see, I equals to 1. It checks whether 6 equals to this 6. Yeah, it's equal. And it's checking whether a of I not equals to last duplicate. This last duplicate value was 0 before. So now a of I, that is 6, is not equals to 0. So it's entering into here and prints a of I is duplicate. A of I is 6. So it prints 6 is duplicate. Now see, now I goes to here. Now it checks whether a of I equals to a of I plus 1. 6 is not equals to 7. So I value gets increased. Then again checks whether 7 equals to 8. No. So I value increases here. Then checks whether 8 equals to 10. No. So I value increases. Now checks whether 10 equals to 12. No. So I value increases. Now checks whether 12 equals to 12. Yeah. And 12 is a of I. That is 12 is not equals to last duplicate. Last duplicate value was the 6. I should update this 0 to 6. I forgot that. Previously found duplicate element was 6 because here it was updated. Now I am checking whether a of I is not equals to last duplicate. A of I is 12. 12 is not equals to 6. So you can print duplicate element as a of I. A of I is 12. So it prints 12 here. Then last duplicate is updated to a of I. Last duplicate was 6. It is updated to 12 because 12 is a duplicate element. Now see, I gets increased towards here. Now it checks whether 12 equals to this 12. A of 7 equals to a of 8. Yeah, it's equal. And it checks a of I not equals to last duplicate. This a of I is 12. 12 should not be equals to this last duplicate, but it's equal. So it doesn't print this 12 again. See, in this case it printed 12 twice, but now it does not print 12 twice. For removing this error only we are writing this condition. A of I should not be equals to last duplicate, and here we are updating last duplicate equals to a of I. This is how you should write the code for finding this duplicate element in sorted array. Now let's see the time complexity. See, now time complexity is O of n. What is this O of n? Why we are writing it? Because this only one for loop is there. For I equals to 0 till I less than n. You are traveling from this I equals to 0 till 9 for searching duplicate elements. Only once you are traveling this whole array. So size of array is n. So we are writing O of n. Now see, now I am going to teach you how to find duplicate element in and count number of times it's appearing in this array. Let's see. This is sorted array. Now see. Now I is at first position 0. Now you should check like previously what I explained, whether a of I equals to a of I plus 1. That 5 equals to 6. No. So you can move I like that. Now whether 6 equals to 6. Yeah. So print it's a 6 is duplicate. That is print a of I. Now suppose I is at this position. Suppose I is at 6. Now let's see. See. Now check whether a of 6 equals to a of 7. Yeah, both are equal. That both are 12. So you should print. You should also tell how much time 12 is repeating. So how much times 12 is present in this array. So you should take another variable for counting j. You should take j. J is 7. You should take 6 plus 1. I plus 1 is j. So j is pointing towards 7. If this a of 6 equals to a of 7, you should take another variable j which is equals to I plus 1. Now you should check you should increase j value by 1 until a of I equals to a of j. See, now a of I, a of 6 is equals to a of 7, that both are 12. So you should increase j value by 1. Now you should again check whether a of I equals to a of 6 equals to a of 8. Yeah, both are 12. So you should again increase j value by 1. Now you should check whether e of 6 equals to e of 9. No, this is 12, this is 15. So you should stop j over here. Now the number of times 12 is repeating is j minus I. See, 9 minus 6 is 3. See, 12 is repeating 3 times. So you should print 12 is repeating 3 times. Now you should update I value as I equals to j minus 1. Now I value will change from 6 to 8. Now you should update this I equals to j minus 1, then again it compares whether a of I equals to a of j. This is the process. Now let's write the code for how to find this. Let's see. Now I is pointing at this starting. Now see, for I equals to 0, comma I less than n, comma I plus plus. This is for checking, for moving from 0 to 9th index, for checking whether any duplicate element is present. Now see, I am writing the condition. If a of I equals to a of I plus 1. Now see, suppose I found here at this index, suppose I is at 6th position. Now a of 6 equals to a of 7, both are 12. Then I should write this. See, if a of I equals to a of I plus 1, now you should take another variable j for counting how many times it's present, how many times 12 is present. So I am writing here j equals to I plus 1. See, j equals to 6 plus 1, 7. Now see, now you should write while condition. While a of j equals to a of I. If till this is a of j equals to a of I, you should increase j value by 1. What is this? See, now a of j, that is a of 7, is equals to a of 6. Then you are increasing j value. Now you are checking whether a of j equals to a of 8 is equals to a of 6. Yeah, so you are again increasing j value. Now it's not equal. A of 9 is not equals to a of 6. So you are stopping. Now you should print what is the how many times it's repeated, that is j minus I times. So I am writing print statement. Now what is this percentage d? This percentage d is, now suppose here 12 is this percentage d. So you should, what is 12? 12 is a of I. It's a duplicate element. So I should write a of I. Then what is this percentage d? That is count how many times it's appearing. So it's that is j minus I. So I should write here j minus I. Now it prints, like suppose at first time it prints 6 is appearing 2 times. So it prints here. Then after I comes here, then it prints 12 is appearing 3 times, like that. Then after this I should update this I value. I should update this I value from 6 to 8. What is this 8? 8 is j minus 1. So see, I equals to j minus 1. I have updated the I value. Then it again starts, it again I gets incremented by 1 and it again compares whether a of I equals to a of I plus 1, whether 12 is equals to 15, and it goes on. Now see, this is the code how to write for finding number of duplicate elements and counting number of times it's appearing in this array. Now let's see the time complexity. See, for this time complexity is O of n. Why O of n? Because you are taking only one time, you are traveling only one time in this whole array, only once. So it takes number of time it takes is size of array, that is n. N is the size of array. So I am writing O of n. Now see, now I am going to teach you how to find duplicate elements and count the number of time that duplicate element is present in unsorted array. Elements are present. This is unsorted array. Now how to find the duplicate element and count number of times it's appearing. Now see, Now for this you should create a hash table. You are creating a hash table. Hash table H. At what size you should create? What is the minimum element in this array? That is what? The minimum element is 3. 3 is the minimum element. So you should create a hash table starting from index 3 till maximum element is what? Maximum element is 11. So you should create till 11. So 3 to 11. Now see. Now see. Now all the elements in this hash table will be 0 at starting. See. 0 0 0 0 0 0 0. Now all elements are 0. Now now see, suppose now 3 is here, 3 is present in this array. So at third index of hash table you should increase one value. So 0 plus 1 is 1. Now suppose 6 is here, then at sixth index of hash table you should increase one value. So 0 plus 1 is 1. Suppose again 6 is there, so at sixth index of hash table you should increase one value. So 1 changes to 2. Like this you should write all elements present in this array. That how it works. Now see, let's see. Now you should take a variable I for traveling from 0 to 9 in this A. Then one by one you should increase. See, now 7 is here. So at 7th index of hash table I should increase one value. Now it becomes 1. Now I increases at this position. Now 4 is there. Now you should search 4th index at hash table. Now you should increase one value in that 4th index. Now I is here. Then 3 is here. So at third index you should increase one value. Now I value increases by 1. Now 11 is present here in this array. So at 11th index of hash table you should increase one value. Then I is at 4. Now 6 is there. So you should increase one value at 6th index of hash table. Then I is at 5th index. Now you should check 5 is there in this index. So you should check 5th index of hash table. You should increase one value in that element. Now see, I is at 6. Now here 6 is there. So you should increase 6. You should search 6th index in this hash table and you should increase one value in that index. Now see, it becomes 2. Now see, I is at here. Now again 6 is present. So you should search 6th index and you should print increase one value. So it becomes 3. Now see, I is here. Now it's 7 is there. So you should check 7th index and you should increase one value. So it becomes 2. Now I is at 9 here. It's 9 is present here. So you should search 9th index and increase one value. So 0 turns to 1. Now see, now you should scan this array from 3 to 11 and you should search whether 0 is present in the whether any element which is greater than 1 is present in this array. Now what is greater than 1? It's 3, this thing. 6 is greater than 1. It's 3 times. So you should print 3. Then here 2 is there. It's greater than 1. So you should print I. I is the I is present A of 5 times. That is 7 is present 2 times. Like that. Then see, this is how you should find number of times this element is duplicated using unsorted by unsorted array. Let's see how to write the code for this. See, now I am writing for I equals to 0 comma I less than n comma I plus plus. This I loop is for traveling from 0 to 9th index of array. For writing, suppose 7 is there, means at 7th index I am marking 1, increasing one value. Then 4 means 4th index I am increasing one value. Like that I am traveling here. For that this loop is there. Now see, now while traveling, now I am for suppose I is 0, then A of 0 is 7. Now we are writing this A of I. So I am writing here A of I. That's 7. Now this 7 will be the index of hash table. We are searching 7 as the index of hash table. So this A of I, this is A of I. A of I will be the index of hash table. So H of A of I. You are writing A of I in the bracket of hash. Now see, now you are searching 7th index. then you are increasing one value. So I am writing here plus plus. Now this loop will this loop is for traveling from 0 to 9 and printing what element are present in that index and increasing one value. That is this thing. Now see, now I am writing another loop for I equals to L, comma I less than equals to no I equals to S, then I less than equals to L, comma I plus plus. Now what is this S? S is 3. S is the smallest index in this hash table. L is the largest index in this hash table, that is 11. Now this I travels from 3 to 11. So I am writing this loop and checking why this loop is traveling, because I am checking whether any element present here is appearing more than one time. So see, more than one time means it's a duplicate element. So I am writing if h of I greater than 1, if this is the condition, see here h of 6 is greater than 1, it's 3 times, so you should print 6 is appearing 3 times. So what is 6? 6 is a of I, no 6 is I, then this 3 is h of I, so you should print, see I am printing, print f percentage d is present percentage d times. Now what is this percentage d? This is I. See, 6 is present 3 times, so this 6 is I. So I. Then this 6 is present dash times. This percentage d is 3 times. It's present 3 times. So what is this 3? This 3 is h of I. So I am writing h of I. Now this is how you should write the code for finding finding the duplicate elements in unsorted array using hash table. Now let's see the time complexity. See, now for this you are taking 0 to 9, the size of array. Only one time you are traveling in this for A array for writing. Suppose 7 is present here, means at 7th index you are increasing one value, like number of times it's appearing, so you are traveling one time, so n time. That is size of array. You are taking O of n for this. Now for this is the loop for traveling in the hash table. You are checking whether any element present here is greater than 1. So this takes n time. You are traveling one time. So this is n. Now n plus n is 2n. Now what is the highest order in this? N power 1. So the total time complexity is O of n. This is the total time complexity. This is how you should find the duplicate elements and also count number of times it's appearing in this array using in unsorted array using this hash table. Now see, now I am going to explain another method for finding the duplicate elements in this array and to count number of elements present in that in unsorted array. See, now I will be pointing here. Let's see how to do. I will be pointing at first 0. Then j will be pointing at I plus 1. That is 1. Suppose j is pointing here. Now see, you should compare. J will be from 1 to 9. Now you should compare whether a of I is equals to a of j. That means whether 8 is present in this, 8 is equals to 3, no. Whether 8 is equals to 6, no. Whether 8 is equals to 4, no. Like that you should travel j one by one. And you should compare whether a of I equals to a of j, like that. If it's equals to j, then you should increment count value. At starting, count value will be 1, because all the element present in this array is present one time. That means default value of count is 1, because all element appears one time at starting. So I am initializing count value 1 at starting. Then see, now I will be here, then j will move from 1 to 9. I'll check whether 8 is present anywhere in this a of j. No means then afterwards I'll move this I value to here. See, then I value will be pointing here at first index. Now j will be pointing at from 2 to 9. Then I will check whether 3 is present in this a of I equals to a of j, whether 3 is here, whether 3 is present here, whether 3 is present here, like that. Then after searching, then again I will move I value. I will increment I value. Then j will be from I plus 1. This j will be from 3 till it moves till 9. So I will check whether 6 is here. Whether 6 is here, yeah, 6 is present here. So I will increment count value. Count value was default, it was 1. Now it will increase by 1. So 6 is appearing 2 times. Now then I will find 6 over here. So I will print 6 is, I will increase count value by 1. So it changes from 2 to 3. So 6 is appearing 3. Like that I will increase I value by 1. Then j value will be increasing by 1 like this. Then I will move I over here. Then I will be pointing here and j will be pointing towards here from 4 to 9. I'll check whether a of 3 is equals to a of 4, whether a of 3 equals to a of 5, like that. Like this. This is how you should find number of times it's appearing. Find the duplicate elements and to find how many times it's appearing in this array. Now let's write the code for this. See. Now for I equals to 0, I less than n, comma I plus plus. Why I am writing this loop? This loop is for traveling from 0 to 9 for moving this. Now see, for checking the duplicate element. Now I should write count equals to 1 in this. In this loop inside I should write count equals to 1. Why? By default count value of all the element present in this is 1 because all element appears one time at starting. So count equals to 1. Now this variable count is 1. Now I should write another condition. If a of I equals to minus 1 is not equals to minus 1. This I will explain at last why I am writing this condition. At last I will explain you. Then see, for j equals to I plus 1 comma j less than n comma j plus plus. What is this condition for? Because see, when a now I is at 0th index, now you should compare this 8 with from j 1 to 9. J value will be ranging from 1 to 9. You will check whether 8 is equals to 3, whether 8 is equals to 6, whether 8 is present here, like that. You will move j value one by one. Then after that, I value will be increasing by 1. Then j will be I plus 1, that is from 2 to 9. Now you will check whether 3 is present here, whether 3 is present here, like whether 3 is equals to 6, whether 3 is equals to this 5, like that. So you need j from I plus 1 till less than n. So I am writing here for j loop equals to I plus 1, j less than n, j plus plus. Now see. Now if I am writing the condition, if a of I equals to a of j, what is this condition? See, suppose now I is at this position, I is at index 2. Now j is from ranging from 3 to 9. Now you are comparing whether 6 is present at index 3, whether 6 is present at index 4. Yeah, it's present. So you should, so you had found a duplicate element. So what you should do? You should increase count value. Count value was 1 before. Now count equals to count plus 1. That means count plus plus. This is same as count equals to count plus 1. Now 6, now see, 6 you have found a of I equals to a of j. That means a of 2 equals to a of 4. So you can increase one value, count equals to count plus 1. So 1 becomes 2 now. Then when j is at 6th index, then you can say count of this a of 2 is equals to a of 6. So 2 value becomes 3. So you can count, now 6 is appearing 3 times. This is how you should write. This is how you should find this duplicate elements. Now see. Now a of j, no, now I should print how many times it's appearing. So see, no, wait, a of j equals to minus 1. Why I am writing this minus 1, I will explain you afterwards. See, I will explain you why I am writing a of j equals to minus 1, and if a of I not equals to minus 1, then only I will enter into this loop. Why I am writing this both line, I will explain you. Now see, now I am writing a print f percentage d is appearing percentage d times. Now what is this first percentage d? This percentage d is the number which is duplicate. The duplicate element we should print here. So this duplicate element is, suppose C, I is at second index. Now A of I is 6. Now you are checking in 6 in this from 3 to 9. Whether 6 is present here, whether 6 is present here, like that. So this duplicate element is 6. What is 6? 6 is A of I. So I am writing A of I is a duplicate element. So here it will print this A of I is 6. 6 is appearing percentage d times. Percentage d for this is what? This is number of times it's present in this array. 6 is present 3 times. So what is 3? 3 is count. So I am writing here count. So this is how you should print. This is how you should print the number of times it's appearing. Now see. Now I will explain you these two lines. Now suppose I is at the I is at the second index. Now see. Now you are comparing the 6 with this j from 3 to 9. Whether 6 equals to 4? No. Whether 6 equals to this 6? Yeah. So see. Now count value was 1 at starting, default value. Now count value will increase by 1. Count is 2. Because you found 6 equals to 6. So count equals to count plus 1. Now see. This 6 equals to 5, whether we are checking whether 6 equals to 5? No. Now we are checking whether 6 equals to 6? Yeah. So again count value increases by 1. So it's 3. Now you are checking whether 6 equals to 6? No. Whether 6 equals to 6? Whether 6 equals to this 2? No. Whether 6 equals to 7? No. Like this. Then after checking, now this I value increases by 1. I will be pointing at third index. Then j will be pointing from 4 to 9. Now you should check whether this 4 equals to 4 is present in any of a of j. Whether 4 equals to this 4 here, 6, whether 4 equals to, whether 4 is present here, whether 4 is present here, like that. One by one I will check. Then now see. Now at this case, when I is here at 4th index and j will move from 5 to 9. Now you check 6 is, whether 6 is present in a of j anywhere. Yeah, 6 is present at 6th index. So now see, count value was 1 at default. Now count value is present here one time. So you should count this a of I equals to a of j. That means a of 4 equals to a of 6. So you should increment one value. See, if a of I equals to a of j, count it plus plus. So 1 becomes 2. Now see, now j value increases here. Whether a of I, this 6 equals to 6? No. Whether 6 equals to here? No. Whether 6 is present here? No. So in this case, see, you have count value for 6 is 2. But in first case you got 3, in second case you got 2. When I is at 2, when you got count is 6 is present 3 times. But when I is at 4, you got 6 is present 2 times only. Now see, in this case, now when I is at 6, then j will be from 7 to 9. At this case, see, whether you are checking 6 is present here? No. Whether 6 is present here? No. Whether 6 is present here? No. So default value for count is 1. So when I is at 2, you got count value as 3 for 6. Now when I is at 4, you got count value as 2. 6 is present 2 times. When I is at 6, you got count value as 1. 6 is appearing 1 times. But see, actually 6 is appearing 3 times. So these two are wrong output, right? So for correcting this value, we are writing a of j equals to minus 1. Let's see why we are writing that. See, now at starting I will be here. Suppose in this case, suppose I is at this position. I is at index 2 and j will be varying from 3 to 9. Now while checking 6 is present here? No. Whether 6 is present here? Yeah, 6 is present. So it increases count value. Count value becomes 1 to 2. Then after becoming 2, this, see, after count is increased, then a of j will be minus 1. This 6 becomes minus 1. Then it checks whether 6 is present here. Yeah. So now count value increases from 2 to 3. Then this place, it places -1 here. So now see, now you got count value as 3 for 6. Then then what happens after placing a of j -1? Then again, now see, now I value increases. Suppose I value was at 2 before. Now then 3 it comes. Then 4 it comes. I value is at here now, suppose. Now j value will be from 5 to 9. Now it checks whether now see, if a of I not equals to -1 here, but a of I equals to -1, we have updated this value. Now see, this is equals to -1, so it does not create a loop, it does not create a j loop. So we no need to find the duplicate for this 6. We have found already duplicate for 6. So again we no need to find. So removing this error, for removing this error only we are updating here a of j equals to -1. And if a of I, if this place a of 4 is not equals to -1, then only we can create a j loop. So for removing these two errors only, we are using this condition, two lines, this line and this line. Now let's see the time complexity. See, now you can see here two loops. One is this for loop and inner side another for loop. Two loops. Two loops means n into n, that is n square. O of n square is the time complexity. Now the other method for finding time complexity is like this. See, when I is at this position, and j is moving from this to this 1 to 9, then this travel is n minus 1 times at starting. Then when I value is increased by 1, suppose I value is here and j value is from 2 to 9, then number of travel for j is n minus 2. So the starting n minus 1, then n minus 2 travel. Then again I will be moved to this second index. Then j will be moving from 3 to 9. Then it will be plus n minus 3 times. Till how much time it goes? Till plus 3, plus 2, plus 1. Like this it goes. So you should add n times. Sum of n elements in the array is what? It is formula is n into n minus 1 by 2. What is this? N into n minus 1 by 2 is n square minus n by 2. What is the highest order in this? N square. So it is O of n square. Like this also you can find the time complexity. This is how you should, now this n square is high time. So previous method which I taught in time complexity of n, that is short method. That is the efficient program, efficient code for finding this unsorted array, finding the duplicate element in this unsorted array. So that's all for today and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.